So I did Halliday Chapter 6, Problem 58. The problem involves friction, centripetal forces, and other simple mechanics concepts. Basically, a car is driving straight towards a wall, and the driver has to brake as to prevent himself from crashing into it. In this problem, the car is 107 meters away from the wall, the initial speed is 35 meters per second, µs is 0.50, and assume that the car's weight is distributed evenly on the four wheels, even when braking. This problem has 5 sub-questions in it. Question A is what magnitude of static friction is required to stop the car completely right before it crashes? Question B is what is the magnitude of Fs max? Question C is provided a kinetic friction constant, at what speed will a sliding car hit the wall? Question D asks what force is required to turn the car in a quarter circle as shown to avoid crashing. Question E asks if this required force is less than Fs max. For all of you folks who don't have time to watch the video, or are just lazy, here are the quick answers. Hopefully this doesn't come as a spoiler. Okay, so let's solve question A now. It is just a simple mechanics problem, so it shouldn't give you any difficulty. Static friction is applied here, since the tires aren't sliding along the ground. From the perspective of a point on the tire, the point simply touches the ground without any horizontal velocity component, as it only touches the ground for an instant and technically doesn't move any horizontal distance while touching the ground. We can use a commonly used formula that relates final velocity, initial velocity, acceleration, and displacement. We can replace acceleration with μsmg divided by m, and then solve for mu. Notice how a negative sign is added after replacing acceleration. This is necessary because acceleration is negative. Finally, we get mu equals 0.584. Now let's solve question B, which is even more straightforward than question A. There is an equation that directly determines the maximum static friction force, and combined with the fact that the normal force is equals the gravitational force, this question is super easy. Plugging in the values, we get Fs max is equal to 6,900 newtons, which is a lot of newtons. Time for question C. Now, let's see how badly this driver will wreck his car. Since the tires are sliding with the ground, kinetic friction is used. And this question can use the same formula as question A, since they have almost identical scenarios, except here the driver is gonna lose some big money from this crash. We solve this question the same way we solve question A, and get 20 meters per second. Considering that that's around 45 miles per hour, there will be serious car damage bills, medical bills, etc. Question D might be a bit more difficult, but it can be solved relatively easily if you know your circle stuff. For the quote-unquote as shown, it is signifying the dotted line curving upward. So, static friction provides all the centripetal force that will take the car on its wonderful journey north. Therefore, use the equation friction force equals centripetal force. It's actually pretty straightforward if you know your stuff, so just plug in away and get the answer of 16,000 newtons. Final question. Don't give up just yet. We already found Fs max in the past, so we already know that the answer to this question is no. RIP driver. If there is any additional lesson from problem 58, it is that you should drive safely, and don't speed too much on the roads.